up to this point, we have been looking at the present value of an annuity or future value of an annuity, and we've been solving for the present value amount or the future value amount. In this next step, this next stage, we're going to solve instead for the actual annuity amount, the payment amount. This is a very useful tool for a number of reasons. One of the things we're going to see is for amortization of loans, figuring out how much has to be paid each period. That's really a present value problem where you're solving for the payment instead of solving for the present value. You know the present value, you know how much the loan is for. Let's start out looking at an annuity equaling some future value amount. So how much must be invested at the end of each year to grow the amount invested to $4,641 at the end of 4 years. So you know how much you want to grow this investment to, so that you know what the future value of the annuity is. You're going to make an investment at the end of every period, so that's an annuity. You know what the future amount needs to be. We're going to take the basic future value of an annuity equation. The future value of the annuity equals the annuity times the future value interest factor for the annuity, and we're just going to rearrange that and solve for solve for the annuity. So if we know the interest rate, the number of periods, and the future value amount, we only have one variable to solve for. That's A. That's what we're doing here. So if we look in our table, and this is Appendix D, for n equals 4 and I equals 1, we can find the future value interest factor for an annuity. And when we look in that, we're going to find the value there is 4.641. So what we've done is found here, we've just found that future value interest factor for the annuity. We know what the future amount needs to be. It's $4,641, so the numerator is 4,641. The denominator is 4.641. That leaves us solving for A. We solve for A as $1,000. So we just plug that in, we find $1,000. Let's look at a present value annuity problem. Again, we're going to solve for the annuity amount, not for the present value amount. We know the present value. Determine what size annuity creates a given present value. That's our standard present value of an annuity problem, equal to present value of an annuity is equal to the annuity amount, payment amount, times the present value interest factor for an annuity. We can rearrange that equation, solve for A. So solving for the annuity, the present value of an annuity divided by the present value interest factor. Let's say you have $10,000. How large can your payments be at the end of each year, making payments? So you're making payments at the end of each year, and I guess this should say for 4 years. Making payments at the end of each year for 4 years. Well, if we look in Appendix D, we find the present value interest factor for n equals 4 years. I equals 6% is 3.465. We have found that value. We have $10,000 currently. That's the present value. The present value of our annuity then is $10,000. And we're dividing by this 3.465. We do that down here at the bottom. We find that the present value, or the annuity payments, are $2,886. Let's look at a table that shows this process. we start with a balance of $10,000. Our interest rate, remember, is 6%. After 1 year, we've earned $600 in interest, which means once we withdraw $2,886, we're going to be left with $714. So we have beginning balance, we earn interest, we take out the annuity amount, we're left with some amount at the end of the period. Now, that value then becomes the beginning value in year 2, and we earn 6% interest on that. Now, we have less to earn. We're earning on less. We no longer have 10,000. We only have 7,700. So our interest amount is less, but our annuity amount is staying the same every period. And you can see here that the total amount that we have available declines every year. The ending balance after 4 years goes to 0. There's nothing left in the account at that point. So that's basically showing graphically how we solve for the annuity amount, and then in fact this works out, not graphically but in a table. Let's look at another example. Here we're going to look at, say, a mortgage. What are the required payments for a $40,000 20-year loan or mortgage if the interest rate is 8%? Well, we know the present value. That's the amount of the loan, $40,000. So we know the present value of the annuity. We're trying to solve for the annuity itself. We can use that formula. Present value of the annuity we know is $40,000. So this term is going to be $40,000. This term we're going to find from Appendix D, because it's a present value problem, and now we're solving for the annual payments that are required. Okay, so in Appendix D we find that that denominator is equal to 9.818. The mortgage amount divided by the amount of the loan divided by 9.818, we have yearly payments required of $4,074. So if we look at our loan payments, we're going to make these payments for 20 years, $4,074. 20 years of payments means that we're going to actually pay $81,480 over the life of the loan. We only borrowed $40,000. So the difference between those two, $41,000, is the amount of interest that we're going to have to pay over that 2-year period. In this case, the interest we're paying is actually more than the principal amount that we borrowed, because we just borrowed it over such a long period of time, over 20 years. We can see here a standard payoff table for a loan, referred to as a loan amortization table. We're not showing all 20 years. If we showed all 20 years, the ending balance would drop to 0 at the end of 20 periods. We're just showing the first year. We essentially have the same thing. We've got to started with that we saw earlier. We start with a balance of $40,000. We make a payment. That's a cash outflow of $4,074. But during that first year, we earned 8%. This payment's actually coming at the end of the year, as all loans do. You can. That's not quite true, but in general, you pay your loan at the end of the year, and you pay the interest at the end of the year as well. The cost and interest was $3,200, so we earned, or rather we have to pay $3,200. We're paying more than that, so some of this is going to repayment of principal, $874. At the end of the first period, we actually only owe $39,126. We've paid off $874 on that loan. we'll go through exactly the same process. That 39,126, we change to a different color. We're going to have to pay interest on that during the next year. That interest amount is 3,130. The interest piece keeps going down. The principal repayment keeps going up. At the end of 20 years, we're paying very, very little interest, and almost all of it's going to repay that principal. Because it's an annuity, that payment is the same every single period. So annuities are very important for sort of standard loans, standard amortization schedules.